So what happens if we're trying to solve a quadratic equation, but we can't factor it? We can't use the square root method, and we can't complete the square. That can absolutely happen where we just get stuck. And if all else fails, we want to use the quadratic formula. So the setup of the quadratic formula is to have ax squared plus bx plus c equals 0. And then with that, we can plug into this formula right here. And what you'll want to do is try your best to memorize this formula because it is going to come up just about the rest of the term with solving these quadratic equations. So let's try this out. If we have 3x squared plus 5x minus 4 equals 0, so first thing I'm going to notice is that this is a great setup of I have 0 on one side of the equation. If we didn't, we would need to move things around, but we're all set up there. Maybe I would try factoring, but I believe this isn't going to factor nicely, so let's go ahead and get plugging in here. So I'm thinking of this with an a of 3, b of positive 5, c of negative 4. And what we're doing is we're solving for x, fitting this negative b plus or minus root b squared minus 4 times a times c all over 2 times a. So I'm going to have negative b, which is 5, plus or minus b squared, so 5 squared, for ac, all over 2a. So we get everything plugged in, parentheses, 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 especially with negative numbers. That'll just guarantee that it simplifies correctly. Now, in simplifying, I think of this in kind of 3 regions. I think of this negative b piece, which in this case is just a negative 5. The second piece I think about is the square root. And the third piece I think about is the denominator, which that denominator is a 2 times 3, which is 6. Then what I'm going to do is simplify underneath the square root, which we can use a calculator to help us out here. So we could plug in, I'm just going to grab my side calculator here, 5 squared minus 4 times 3 times a negative 4. So that comes out to a 73. And we're going to talk about simplifying radicals later on in the term. So at this point, we could just leave it like this. If you can take the square root, if it's a nice square root, we would do that, but this is going to stay like this. And you could leave the answer just like that, or if you want to split into the 2 scenarios, we would have x is negative 5 plus root 73 over 6, and x is negative 5 minus root 73 over 6. And you know what? I said to leave it like that, but let's do a quick lesson on simplifying radicals since you've maybe seen it before, and if you haven't, we'll go into much more depth next time. I believe next week we'll talk about them. What I'm thinking of is root 73. If I break that into factors, that is multiplied with a 9 times 8. Nope, never mind. I was doing quick math in my head and it didn't work out, so it doesn't simplify. So I'll find a case in one of these next ones that does. So this would stay just like that, unless we went to get a decimal, which we'll really just do for word problems. So let's keep it like this. Ooh, there we go. Okay, just like that. Let's go to our next one here. Okay, so I have 0 on one side of the equation. That's my little mental check first. And then we're working with a equals 8, b equals negative 2, c equals negative 1. Okay, so we're going to have x equals, and I set up my format here, and I like to do this kind of shell of the pieces first. So I have my parentheses all set up, and then it's just a matter of putting them in the right spot. So negative b, so in the parentheses we'll have a negative 2, b squared, so negative 2 squared, for ac all over 2a. So with this, negative 2 is a positive 2. We'll have our plus or minus. In the denominator, we have 2 times 8, which is 16. And here we'll have the square root of 4 plus 32, which is 36. So square root of 36, we can simplify that. So we have a 2 plus or minus 6 over 16. So we're going to get some nice numbers out of this. Well, it'll be fractions, but nicer than with the square roots. So we have 2 plus 6 over 16, and we have 2 minus 6 over 16. So that is 8 over 16, which reduces down to a 1/2. Here we have a negative 4 over 16, which will be a negative 1/4. So that one we might have been able to get out of factoring, and actually we could have gotten this out of factoring, but maybe the factors aren't obvious at the beginning, and you can always go to the quadratic formula. You can always apply it. But our rules before, like the factoring, the completing the square, and the square root method, had very specific setups to them before we could plug in and solve. But quadratic formula, all we need is 0 on one side of the equation. Okay, with this one, now we don't have 0 on one side of the equation, but that's easy enough to fix. What we can do is add 2 to both sides. And just to take you through my thought process here is I would actually try factoring first with this, but trying to think of 2 values that multiply to 2 and add up to 7, we're going to get stuck. So with that, I want to use quadratic formula. Now we could use completing the square here, and just for a bit of a messier example, I'll put that over to the side here. So we'll stick to our quadratic formula, but I just want to show you a scenario where we could do completing the square as well. Why I'm thinking it's possible is because a is equal to 1 here, so we could go completing the square. But let's start with our quadratic formula. So a is 1, b is 7, c is 2. So we're going to have x equals negative b plus or minus root b squared minus 4ac all over 2a. And we're going to plug in negative b. I feel like I messed up my colors here, but we'll get it. B squared minus 4ac all over 2a. Okay, so x equals, we have a negative 7 plus or minus over 2 square root, let's see, 49 minus 8 for a 41. And we're not going to be able to simplify that square root there, so we're going to leave it just like that. If we wanted to, we could split it up with x equals a negative 7 plus root 41 over 2, and x equals negative 7 minus root 41 over 2. That works as well. Let's talk about if we went the route of completing the square here. Actually, I would leave this in that form, x squared plus 7x. I'm going to be adding something on, equals a negative 2. Now, completing the square here, so what I would be thinking of is 7 divided by 2 and squaring that, which is going to make a fraction for us, but we can do it. This is a good review of some fraction skills. And if I add that, I need to add it to the other side as well. So this would be x plus, and then 7 divided by 2 as a binomial squared with how we set that up equals adding those fractions together, let's see, that would be a negative 8 over 4, so that's going to be a 41 over 4. Take the square root of both sides. So we'll have x plus 7/2 equals plus or minus, and then I'm going to leave the numerator as square root of 41, but in the denominator I could take that square root of 4, which is 2. I'm going to subtract 7/2 from both sides, so I'm going to have a negative 7/2 plus or minus root 41 over 2. And then I could combine those into a single statement where I have in the numerator negative 7 plus or minus root 41 all over that common denominator of 2. So we end up in the same exact spot. It's just a little messier with those fractions, but in case you went one route versus the other, you'd end up at the same location. Okay, last one here. What if it's something messy like this, and you're seeing those factors, and you're like, ooh, I could just set those equal. I'd have x plus 1 equals 1, 3x minus 1 equals 1. We can't do that. It has to be 0 on one side of the equation. So what I need to do is actually multiply all of this out. So I need to simplify this left-hand side of the equation. So with that, I'm going to FOIL. So I'm going to leave the 2 on the outside, and then I'll have x times 3x is 3x squared, minus x plus 3x, so plus 2x, positive 1 times a negative 1, minus 1, equals 1. And then I'm going to go ahead and distribute the 2 through, so 6x squared plus 4x minus 2 equals 1. And now that it's all simplified, I can subtract 1 from both sides. So 6x squared plus 4x minus 1, nope, minus 3, subtract 1 from both sides, equals 0. And then we could try to factor it, or nope, no completing the square, no square root method. But let's go with our quadratic formula. So a is 6. B is 4, C is negative 3. So x is equal to negative b plus or minus root b squared minus 4ac all over 2a, and we'll plug in our values with a negative 3 right there. Okay, so we're going to have x equals negative 4 plus or minus all over 12. And then we're going to have the square root of 16 plus a lot. So in the calculator, that should give us 40. Now let's talk through a brief example of how to simplify that square root. And there's a few different ways to do it, and we can talk through all of the different ways. But what we could do is kind of the exhaustive way, which might be a good place to start if you haven't been doing this. If you have your methods and you know how to get to there, absolutely go for it. But just to show you kind of the exhaustive method would be to get the prime factorization, which would look like, let's see, 40 can be divided by 2, which would leave me with 20. Divide that by 2 would leave me with 10. Divide that by 2 would leave me with 5. And I would have my prime factorization. So 2 times 2 is 4, times 2 is 8, times 5 is 40. So I just rewrote 40 in this factorization. And with a square root, what we're doing is looking for perfect squares. So I can see as I have this pairing of 2 times 2. So what that lets me do is take out a factor of 2. So that'd be like having the square root of 4. So square root of 4 is 2. And then stuck under the square root, 10 is still hanging out with that 2 times 5. So what we could do is rewrite this as x equals negative 4 plus or minus 2 root 10 over 12. And what we could do is then split this up so that we could simplify. So a way we could simplify is rewriting this as x equals negative 4 over 12 plus or minus 2 root 10 over 12. And then we could see our common factors. So 4 divided by 12 is a 1/3. Plus or minus 2 divided by 12 is a 1/6. So root 10 over 6. And we would have a simplified form in that way. So that's how we would simplify our final answers if we needed to. But we can often leave them in the more complicated forms when we can't simplify that square root.